And thank you everyone for joining us today. This is a webinar with CBI and with Hewlett-Packard Enterprises. And what we're looking at today is how to defend against compromised data, right? So we know that attacks are going to happen. We're going to walk through what some of those attacks look like. And we know that there's technologies available, but understanding what the threat landscape is and how that intersects with what controls we have and how everything all plugs together, and making a logical strategic decision on what goes where and when and why. You know, we struggle with that. We struggle with that a lot. So those are some of the things we're going to look at today and we're going to cover. A bit about me. My name is Wolf Goerlich, as already mentioned. I'm the Director of Security Strategy here at CBI. Been in IT for far too long. I've been in IT security for the past 10 years. And as part of the strategy team, our strategy team is all former IT and IT security leaders, right? CIOs, CISOs, what have you. And our role is really to understand security programs, to understand what it's like to sit on the other side of the table, to understand, you know, the day in the life of the CISO, and figure out how it can better rationalize the products and services and everything that IT security firms such as CBI offers, so that we can solve real-world problems. The agenda is to look at the threat landscape and the need for encryption, and then we're going to look at data flows and how to assess the application of encryption on those data flows, and talk about how this leads naturally to data-centric security. And at that point, I'm going to turn it over to Sudeep, and he's going to take it from there and talk about how data-centric security can be realized and achieved with HP enterprises. So, of course, the big question is always why, right? Why look at encryption? Why look at these technologies? The fact is, we have very much a key in the car problem with a lot of encryption, because we have the encryption there. We think it's in the right spots, but yet the breach still happens, and you're wondering, well, why? I thought we checked the box. I thought we're okay. What do you mean we still got compromised? There's several ways that you can have the utmost security, and yet by missing the right control in the right place, still leave yourself open to compromise. And likewise, you can go the opposite way, right? So I want to protect my car from getting stolen or broken into. I want to keep the kids from, jimming the locks and breaking out the ignition switch. I'll buy a tank. And as we all know, none of us can afford a tank. We don't have time or the resources to do something like that. So it comes down to us to try and figure out where the weaknesses are and where the attacks are coming from, so that we can make some good decisions. One of the ways we do that is by this concept of attack paths. You may have heard this on previous webinars. The way of doing threat modeling is it's oftentimes used by CBI for incident response readiness, but it has a very real application when it comes to encryption and where encryption should be. An attack path is, I like to think of it like balloon tower defense. I don't know if anyone else, but if I got like 5 minutes on an elevator, I pop open balloon tower defense and pop some balloons with some monkeys. I mean, you know, we got to burn off some steam, right? So if you think about balloon tower defense, you got a path, and that path is the route that the criminals are naturally going to follow when they're breaking into your network. You got your monkeys, you got your controls, and those controls oftentimes will miss. We know this, right? Phishing exercises often show that 50% of the time people miss. People don't report, and the phish gets through. But 50% of the time they do, right? So you begin to look at the percentage likelihood of each control to be effective. Antivirus are at 60-70%. Each one of these controls has a certain percentage, and so we build defense in depth along that path, knowing that any one control is not 100%, knowing that any one control can and will fail, and thinking about what happens after that control fails, what happens next on that path, and where do those controls naturally shift the criminal. So if you look at some common attacks, right, like the number one thing we see if you go and look up data loss is like the stolen laptop. You got the laptop, it's in the car. Hopefully you didn't leave your keys in the car. But you got a laptop, it's in the car, and because of some business process, people have been placing sensitive data files on this laptop. I heard once a great analogy. A guy's like, look, we've got our castle, we've got our fortress, I've got walls, I've got controls, I got access to this, I got segmented that. I got everything I need to protect my Oracle database. And then I promptly let a user extract whatever they want, put it in a CSV file or Excel file, and send that file on its merry way. Protecting that data after it's out is very, very difficult. And this is one of the common sources we see. So here's where you look at things like file level encryption or disk encryption. If you can prevent that computer from being read, you've got a fighting chance to not have a breach. Another way we often see, and this is similar to what we saw with Anthem, is again thinking about phishing controls, right? 1 out of every 2 people is going to click on the link. Statistically, we know that. What does that mean when the person clicking on the link is a privileged user? What does that mean when the person is, say, a database administrator? So you have your health information, it's stored, secured, it's in the fortress. Hopefully you've done something to mitigate the risk of data files transmitting out. Maybe it's disk encryption, file level encryption, what have you. And along comes a criminal and they phish your DBA, and then as those DBA creds, they log in and they extract that data and they exfiltrate it. And again, you got a breach. So here's where we start to look at things like column level encryption, database level encryption. What can we do within those individual data items themselves? Or another thing we can think about is on the PCI side, right? So what about the common breach that we see all the time? And this is similar to what happened at Target, where the criminal gets in, they got onto the point of sale system, and due to a lack of encryption at key areas, either on the point of sale system or back as the credit card information flows to the networks to the payment processors, they're able to scrape that card information in the clear. They're able to aggregate that card information in the clear, and then they exfiltrate it, and again, now we've got a breach, right? We've lost sensitive health information in the earlier couple examples. We've lost sensitive payment information on this example. And so each one of these examples, as we build these attack paths and we build these models, we can begin to say, okay, here's the common ways a criminal is going to navigate through our system. Here's what those common tactics look like. What do I need for monkeys, right? What do I need for controls, and what's the right place to put the preventative and detective controls in place? Another way that we can look at this from an encryption standpoint is looking back at CBI's 8 encryption domains. So just a quick reminder what those 8 domains came from. They came from talking with our penetration testing team, who is almost always, I think they have a 100% success rate breaking into companies, and we never go after companies, right? Companies never say, hey, CBI, will you assess us? And they don't have encryption. All these companies have encryption, yet my red team is always successful. It comes from our security operations folks when they do incident response. So we looked at ways criminals break in, we look at the ways the red team is successful, and we began to build controls to thwart them. And then we cross-referenced it with regulatory compliance and mandates. What does PCI say? What does HIPAA say? NIST, et cetera, et cetera. And combining those, we came up with the 8 domains that can follow along that same path and look at each step of an attack and figure out where we need to apply encryption and make good decisions. Now that's from the attacker perspective, right? That's from the criminal perspective. That's the path they're taking through our networks. What about the opposite? What about not the abuse cases, but actually the use cases? When you start to look at use cases, you can start mapping out data flows. Probably the easiest way to do this is in the PCI environment, where it's been mandated for quite some time that we actually map out those cardholder data environments and map out those data flows. So it could be something very simple, right? Someone makes a call to a call center, and the call center may print out some forms, and those forms get shredded, and in processing those card centers, they log on to different websites, and how does that communication flow? What goes where? Or it could be something more complex. It could include all the way back from the forms and the people who call and the various applications that are needed, all the way back to the credit card processing systems themselves, back to the merchant bank, and all the way back to the card issuer. If we start to map out these data flows, we can get a sense of how the sensitive data is maneuvering and moving throughout our systems, and where those junction points are, that it's in the clear, that it's susceptible, that it's open. And that, of course, with PCI is immediately applicable for compliance concerns, right? Thou shalt tokenize, thou shalt, um, use this particular encryption over a transport layer, thou shalt not use SSL, those types of things. But of course, again, it goes right back into health information too, which even though HIPAA is a little bit higher level, is just as important. We may have some sources of patients and customers. We may have some different applications that they're using. And all this is going on in the back end with some claims processing, and then it's sent to our data warehouse and our online transaction systems, and there's a staging system involved. Mapping these things out is really critical to figure out where that sensitive data is and where it might end up. And as we all know, data is like water. It's always going to end up where we least expect it, and it's always going to escape whatever boundaries we put around it. So then what can we do once we have these data flows? Well, very similar to the attack path example, we can apply those 8 encryption domains to that data flow as well. So assess the data flow, look at the control requirements based on the type of data it is and the type of processing or storage or transmission that we're looking at. Document the business case. Why do we have this process? What does it mean to our organization? What's the revenue it's generating, et cetera, et cetera? Is there high volume transactions? Is there a high amount of PII? Is this a critical business process? Once we have that business case and that business relevant information, we can then begin mapping it to existing and future products. What do we have now that can plug these gaps? And what do we need? And with that information, we can begin to integrate it within the security roadmap. So again, we can look at those 8 domains. We can go through a very similar exercise, and we can start filling in some of the information about the requirements and controls that exist and get a sense of, are we locked down? Do we have the green lock and checkbox? Are we good? Or do we have some work yet to do? And of course, our valid answer is always, hey, we have some work to do. We're on the roadmap, or maybe this isn't high transaction. Maybe this isn't high risk. Maybe we need to revisit this flow and re-architect it. There's a myriad of different ways we can look at this. But the key point is, with the intersection of the threats to data and the intersection of the data flows as captured by your traditional IT infrastructure, we begin to cross-reference those 2 areas. Now, this particular slide, Sudeep's going to go into more depth in a couple minutes and talk about where and how HP plugs into all these areas. But the key thing is, at each level, right, from data and applications to your middleware, your database, your file systems, all the way down to your storage, at each level, there's of course some traditional IT infrastructure in place that can protect it, your firewalls, your database encryption, your TLS, what have you. And of course, there's some real threats to it. Malicious insiders, people stealing that laptop, people phishing and getting your credentials, people extracting your database, either intentionally or unintentionally, and leaving that data in the clear. And as we do this exercise, as we find these intersection points, and this is where we can begin to identify where we have the most leverage and where we should be investing the most of our resources. Because it's at that intersection that we can have the greatest impact on the security posture. And needless to say, unsurprisingly, encryption is one of the main areas where organizations are looking to invest. This slide comes from the Ponemon Institute. They did some research last year looking at the cost of cybercrime and where the return on investment is. And a lot of it comes down to the extensive deployment of encryption technologies. It is a very good way to move the needle, providing it's done in an intelligent way and is part of a cohesive security strategy. Well, a lot of this begins to shift us toward, right, when you talk about all the different encryptions, all the different ways that data can be exfiltrated or compromised, is this concept of a data-centric security posture, which is to say, just like we used to say, let's move the security controls close as possible to the device, let's move the security controls close as possible to the application. When we begin to talk about encryption, it becomes ever more clear that we need to move that control, we need to move that encryption as close as possible to the data itself, to those individual data items, such that if it is extracted, if it is sent to a file, if there is a phishing attack, if it is flushed to disk, whatever it may be, that protection flows with the individual data. And it's only going to become more sensitive and more important as we begin to look at newer technologies such as Hadoop and other ways of doing data in the cloud and what have you, right? We need those controls to be persistent and consistent regardless of the device or the infrastructure. So just summarizing my intro before I turn it over to Sudeep, whenever we start to look at these things, whenever we start to talk about building a roadmap, there's always a lot of fog. There's always a lot of unknowns. We find ourselves very often kind of stumbling in the dark, right, going on this dark road because we don't necessarily know what the real attacks look like. We don't necessarily know what the real concerns are going to be. We don't necessarily know what technologies we have in place. One of the ways to kind of clear the fog and to essentially begin to create your roadmap is what I talked about in the beginning of this webinar. Let's use a controls and maturity framework and assess a specific area. Using that controls and maturity framework, model out what the criminals do, right? Model out what a real attack looks like and assess it back to those controls. Look at the data, model out what the business process is and where that information is going and what the sensitive information has. And most importantly to me, is how that individual process contributes to the organization and allows the organization to meet its mission. So map out the route the criminals take, map out those data flows, and then come to the intersection of attack and defense and look towards data-centric security solutions. With that, I'm going to turn it over to Sudeep to take us into the second part of this webinar.
Perfect. Thank you so much, Wolf. That was a great introduction and a great setup. So to the audience, as a quick introduction, my name is Sudeep Venkatesh, and I run the pre-sales team for what is HP Data Security. And I come to HP through its acquisition of Voltage Security, which happened in February of last year. So, Wolf, essentially, I'd like to revisit one of the slides that we discussed before, and this should be familiar to most folks in our audience. This basically lays out a typical OSI stack, and one of the points that we wanted to bring across here is that not all encryption is the same, and the value that you get from encryption depends upon where in your stack you deploy it. So, for example, there are many great storage level encryption products, but they give you protection against someone walking into your data center and stealing your hard drive. Similarly, there are several encryption products that operate at the column level, but if you research them a little better, you will see that they offer you great protection, again, against someone walking away with your hard drive and also against loss of backup files. And then all of us are quite familiar with TLS, with VPNs, with various network level encryption protocols as well. Again, it's important to realize that the data is protected as soon as it enters a pipe, but on the other side, it comes tumbling out in the clear. But most of the attacks that we're seeing nowadays would not have been remediated by one of these encryption technologies. What we are talking about and the concept that we're bringing to the market is this concept called field level protection or data-centric protection, where if you take sensitive data elements like credit card numbers or social security numbers, name or address fields, and if you protect them from a field level, then it does not matter where that data flows up and down your stack, and nor does it matter whether it flows from stack to stack. So for example, an organization could capture social security numbers through a web interface from its customers. If it encrypts those social security numbers from a field level, then it doesn't matter if they end up into some sort of a settlement or credit check application in mainframe. If they're then taken to Hadoop for a data analysis perspective, they're still protected. So it is this concept of field level protection or end-to-end protection that we're bringing to the market. Now, technologies that did field level protection have been around for about 40 years. So DES, for example, was invented in the 70s. However, the problem with older ways of doing encryption is where if you take something like a name or a social security number, and if you encrypt it, the resultant output becomes a large piece of garbage. So this is extremely corrosive on your applications and databases, because databases many times are cached, for example, to accept 9-variable character for social security numbers. Your applications in Java, for example, might have been cast or programmed to accept strings in the form of names for names. So one of the technologies that the audience should get familiar with is a technology called format preserving encryption, where you can take data elements like bank checks, as it's shown on the screen, dates, social security numbers, etc., and you can encrypt them such that the resultant output has the same format as the input. So the business benefit of this is that now you can take your sensitive data, you can encrypt it with strong AES encryption, and you can proliferate that data throughout your organization. And now if systems that hold encrypted data get breached, you are essentially protected. So the value of format preserving encryption is that now you can have field level protection or data-centric protection across your enterprise without having to change the vast majority of applications. And we've literally done hundreds of deployments in the real world with this. And what we see is that 80 to 90% of applications can work with data in its protected form. And it's only a small number of applications that need the change to be able to look at real data or to be able to process data while it's being protected. So we see a number of applications for this technology. Obviously, folks are protecting production systems. They're also using this as an effective technology to develop test dev. They're using this to proliferate the use of Hadoop and HDFS. And they're also using this technology to enhance or escalate their migration to the cloud. And I'll certainly be talking about 3 real life customers towards the end of today's presentation as well. Now, the type of protection that you pick should be called for by, for example, the regulatory compliance that you're looking to achieve there as well. So many times, the PCI industry, for example, requires that credit card data be tokenized for systems to be out of PCI audit scope. So along with format preserving encryption, there is another technology, a very separate technology called tokenization that is offered here as well. Now, traditional tokenization technologies essentially have large backend databases that they use to store the relationship between your card data and your tokens. Now, of course, since these are databases, they grow in time. And once you have millions or hundreds of millions of credit card pieces in that database, it becomes slow and it becomes difficult to replicate as well as to scale. So another technology that you should look into, especially when you're looking to take systems out of PCI audit scope, is a technology called secure stateless tokenization. So as opposed to older or traditional ways of doing tokenization, where you have to store the relationship in a backend database, with secure stateless tokenization, you can actually generate or you can look up the relationship between card data and its token using smaller lookup tables. And nowadays, technologies that do secure tokenization can have a number of different formats as well. So for example, one format you would see out there is called obviously protected format, where instead of having numbers in your tokens, you could also give alphabets. So just to summarize, format preserving encryption is normally used in the industry to protect what's called PII, or personally identifiable data, while tokenization is typically used where you want to protect credit card data to take systems out of PCI audit scope. And over the last 5 or 6 years, there have been a number of innovations in both those areas. Now, wherever you have encryption, Wolf was mentioning the concept of locking a car or a door, but then also being careful about how you're managing those keys. So similarly with encryption, you have to make sure that you're using strong and robust key management when you're managing those encryption keys. And over the past couple of decades or so, the industry has moved to this concept of central key management, where you have a central key management and policy management layer where keys are managed, keys are issued, etc. And then you have a number of applications that are using APIs or tools to do the actual encryption and decryption. So traditional key management technologies essentially used the concept of a key vault, which again caused problems with scale, with disaster recovery as well. So some of the new technologies out there support this concept of stateless key management, where again, you're not storing your keys in a central database, but you are generating keys on the fly as and when required on a central server. So of course, as you can start seeing this, stateless key management offers a number of advantages in terms of scalability, in terms of disaster recovery as well. For example, one of our large customers has 15 of our key servers divided across 3 data centers. Now, since these servers support the concept of stateless key management, they do not have to replicate key data amongst each other, but can all respond with exactly the same key because they're all deriving symmetric keys of a same base key. So this concept of stateless key management is certainly what you should look at when you're investigating encryption solutions. Now, this is a slightly different view to the problem, and this is how I'm talking to my audience more and more. The slide that you see on your screen is your enterprise, right? So you have data in this red table sitting in the clear. As you can see, you have names, you have social security numbers, you have street addresses as well. And now anyone who can get access to these servers or to these systems has access to that data. So what we are essentially saying, I mean, among these folks, you might have authorized folks like analysts, you could have authorized help desk people as well, but sometimes folks like malicious users or malware can cross firewalls, they can escape detection systems and get onto these servers, which is how a lot of breaches have been happening recently. So what we essentially do is that we take this clear data and we use technologies like format preserving encryption or tokenization, and we flip that data in its protected form. So now, as you can see, the data from a distance looks like real data, but once you observe closely, the names have all been encrypted, the credit card numbers have all been tokenized as well. So in this case, if malware does happen to get into your system, if one of your insiders does turn rogue, you have you will lose data, but it'll be data in its protected form. Similarly, DBAs, for example, can keep upgrading servers. They can upgrade, different system administrators can upgrade their Unix versions, for example, as well, without any risk of compromise of that data. Now, the vast majority of applications, so what we're seeing in the industry is that the vast majority of applications can operate on that protected data itself. So help desk applications, for example, that need just the last 4 digits of a social security number can read the protected data as it is, ignore the first 5 that were protected, and just use the last 4. So in this case, if that help desk application is breached, you are still protected. Similarly, a payments application, for example, will read all 16 digits of the credit card number, but will only use the first 6, which happens to be in the clear, to be able to route these transactions to a settlement server. And again, as you can see, if that payments app gets breached, you're protected. However, you might have applications in your environment that need the real name because they're part of an HR application, or might need a user's real social security number because it's part of a collections check that they're doing. In that case, they can make calls to a product API or to a product tool under the right authentication policies, under the right authorization policies, and then reverse the protection on that data. So this is a very important slide which shows that this data protection is reversible to the right applications and systems in the right context. This slide essentially shows you the architecture of the product that we bring to the market, which is HPE Secure Data. So the product has a 2-tier architecture. On one layer, you have key management and policy management appliances. These appliances are provided as ISO images, so customers can load them on VMware or can load them on any Linux compatible hardware. And then they come with a browser-based management console that can be used to manage policies. They can optionally connect to a hardware security module for additional security of base keys. And they can also talk to authentication and authorization systems like LDAP or AD to authenticate users as well as to authenticate administrators. And then from an application side, there are a few basic ways in which you can get encryption or tokenization done. So for example, there is a C, C++, Java API, which with 3 or 4 lines of code can be integrated into your application to encrypt or decrypt data. Now, this API is available on a number of different platforms, including Windows, Linux, ZOS, HP Nonstop, etc. There is also a file processing tool available, and this tool is essentially used to protect data within files as it's passing within environments. So many times what we see is that different applications like ZOS and Oracle share data through the use of files. Also, a lot of new data coming into an organization comes through structured files like XML, JSON, CSV, record delimited, positional delimited, etc. formats as well. So the file processing tool can operate on those entities. And then the product also provides a SOAP and a REST API, which in this case can be used to invoke encryption or tokenization operations. And in the case of the REST API, even many commercial off-the-shelf applications like business intelligence tools, packaged HR applications, etc., support making SOAP calls or support making REST calls. So that's a great way to integrate them into the ecosystem for doing encryption and tokenization. And then these basic tools have been taken and integrated into a number of different platforms and systems. For example, you could call these tools in an ETL landscape. So if you have products like Ab Initio, IBM DataStage, or even Informatica, Power Center, you can integrate them with the APIs to encrypt or tokenize data. These tools have been taken into various payment terminals as well. So, companies like the Home Depot, for example, use payment terminals that are integrated with the Voltage APIs to protect credit card data right at the point of swipe. We've integrated our tools as UDFs and stored procedures. We've also integrated our tools natively into the Hadoop platform. So we certify with the 4 most popular distros out there to make sure that we integrate into Hadoop tools like MapReduce, Hive, Scoop, as you're importing data into Hadoop or as you're running queries. So this is a high-level architecture of what the system looks like. Now, as I'm bringing this home and opening it up for questions, there were 3 different customer case studies that I wanted to talk about. One is our largest customer, which is a US-based telco. The board for this company mandated a few years ago that any sensitive data that they might have of customer info or employee info has to be protected. This company looked at several different point solutions and figured out that they would need up to 72 encryption solutions to be able to meet all their platform requirements. What they liked about the HP Secure Data product is the concept of field level protection. So that way we're agnostic of the underlying operating system, we're agnostic of the underlying database, and we operate at a field level. So this organization quickly recognized that they had 26 different data elements that needed protection, and they integrated the HP Secure Data tools across 550 different applications. So as I had mentioned before, they have 15 voltage servers deployed in 5 different data centers, and the most important thing is that the solution needs less than 1 FTE to manage. So this company has a small center of excellence for the secure data tools and APIs, which is managed from their CISO's office. And they essentially have deployed this across 550 different applications, including Windows, Linux, ZOS, HP Nonstop, etc. as well. So a great showcase for us to show how an organization can deploy field level protection or data-centric protection across millions and millions of data elements. The second example that I wanted to talk about is a leading car manufacturer. Now, because of certain safety reasons, this car manufacturer decided to put a number of sensors in different vehicles. So they're putting up to 15 sensors in 5 million vehicles that are capturing a lot of sensitive information, including VIN number, including GPS location, and sending that into a central repository. Now, that information by itself is not PII data, but when you combine someone's VIN number with their GPS information, then you can track exactly where they were this last weekend, and that, of course, is a big privacy issue. So this car manufacturer started with deploying the HP secure data tools on its Teradata and Hadoop platforms. So as the sensors are sending data into a central repository, they're being encrypted using format preserving encryption, and the majority of that analysis happens on the protected data itself. So this is a great example. A lot of folks talk about the Internet of Things. There's a lot of marketing hype about the Internet of Things, but this is a great example where from a practical perspective, we have protected a deployment that is using the Internet of Things to collect vast amounts of data. The last use case that I want to talk about is a large e-insurer, and they essentially are some handsets, phone handsets. They're a new style of insurance company because they want to move a lot of their infrastructure to the cloud, and we are an extremely good enabler for that. So if you think about it, if someone is using an infrastructure as a service like Amazon Web Services or platform as a service like Microsoft Azure, format preserving encryption and tokenization are great methodologies that you can use to encrypt those data elements before sending them to the cloud. So we work with this insurer. We also work with a large credit card brand. And this credit card brand realized that they could save up to 90% of costs if they moved some of their Windows servers into Microsoft Azure. Now, these servers had business-facing applications, so these servers were then enabled with the HP secure data tools, so that data was protected from a field level as soon as it entered Microsoft Azure and then stayed protected through its life cycle. And it was only a small number of authorized applications and users that made calls to the tools to get that data decrypted as well. So again, what we're seeing across the industry, may that be financial services, may that be insurance, may that be manufacturing, organizations are realizing huge cost savings by moving applications to the cloud, but with the use of data-centric security, they're remediating some of the security concerns and risks there.
Thanks a lot, Sudeep. Really appreciate you going over that and giving us the additional color. Thanks again for everyone joining us today as we've been talking about looking at how to protect against compromised data and looking at how to develop a data-centric security model. One of the things that CBI does with partners such as HPE is to assist in incident response planning to ensure encryption is protecting against those threats, as well as an encryption assessment to ensure that the right products are in the right place. Outcomes of that being an idea on terms of focus, agenda, roadmap, and total cost of ownership. So the email for our strategy team is on the screen along with the telephone number. Reach out anytime you want to discuss this and related topics. We'll be happy to dig into it in any depth. So thank you very much and enjoy the rest of the day.